All right, for these next couple of examples, we're going to find the missing side lengths. For example number 2, it says triangle DEF is similar to triangle MNP. Let's go ahead and find the value of x over here. So the first thing that I want to do here is I'm going to create a ratio based off of the image and the pre-image. The image here is going to be triangle MNP, and the pre-image will be triangle DEF. So we can set up this scale factor as 30 over x. We don't know what the scale factor is, but that's what we're going to find out right now. To find out our scale factor, let's compare it with the proportions of the corresponding parts here as well. We know that 30 over x is the same thing as NP over, so NP over EF. The scale factor should be the same for all of the side lengths. So let's compare it to another side. I'm going to compare it to DE and MN. So let's see. MN over DE is going to be 18 over 15. So let's take a deeper look into this fraction, this ratio over here. 18 over 15 is equivalent to 6 over 5. So we're going to assume right now that our scale factor k is 6 over 5. So if this is true, then 30 over x has to be the same scale factor as 6 over 5. And in order for us to solve for the missing variable x here, what are we going to do to both sides? Well, a shortcut that we can do is something called cross multiplication. If we set up ratios to be equal, we can cross multiply to find out missing values. So 30 times 5 over here is going to equal 150. And then x times 6 is going to give us 6x. And then to solve for the missing variable x here, we're just going to divide both sides by 6. So x is going to equal 150 divided by 6. Let's see, 6 divided by 150, 212, 305. So x is going to be 25 here. So the missing side length, x, is going to equal 25. And let's go see if this is going to still be true for our scale factor. So remember, NP over EF is 30 over 25. And if we were to simplify this fraction, it's going to become 6/5, which is our scale factor. So we've just proven that our scale factor works for this as well. Okay, let's try out another example. Example 3 says, triangle TPR is similar to triangle XPZ. Find the length of SP. So SP is going to be this altitude right over here. And altitude is the line that goes from the apex of a triangle to the bottom. Okay. To the base. All right. So triangle TPR is similar to triangle XPZ. So I notice two side links here. We have X all the way to Z over here, and then T to R. These look like they're going to be similar. And it's true because X to Z is in the same position as TR. So they are corresponding here. So let's set up a proportion, a ratio. So XZ, and I'm putting XZ first because that is our image. That's what happens after. And then is going to be over TR. What are these lengths going to be? So from X to Z, it is 8 and 8. So 16 over 6 and 6, which is 12. Let's simplify this fraction. These are both even numbers, so I could do 8 over 6 and then 4 over 3. So right now, we have a scale factor of 4/3. And let's go ahead and apply the same logic to this 20 over here, and then this missing value over here. So from P to Y, so from P to Y, we're going to set it a proportion from P to S, PY is 20 over PS, which we don't know yet. So I'm going to put the variable X instead. So again, let's set this up as a statement of proportionality. 4/3, which is our scale factor, has to be equal to 20 over X. Again, let's do a shortcut where we can cross multiply. I'm going to move this up here. So 3 times 20 is going to give us 60 over 4x. And then we're going to divide both sides by 4. So x is going to equal 60/4. How many times can 4 go into 60? That's a great question. At the top of my head, I do not know, which is super tragic. 20, 15. Oh, 15 times. So x is going to equal 15. So our missing side length, 15, will be that, what is it? PS, or SP rather. SP is going to equal 15. And let's double check our work here. So if our scale factor is 4/3, it should be equal to, let's see, 20 over 15. Is 20/15 the same thing as 4/3? Yes, it is. Therefore, we have just proved that segment SP is 15. Okay, that's it. Bye.